questions on the homework before we get started? Mm-hmm. All right, guys. There's no question over the homework. What we're doing today is completing the square. We're solving by completing the square. Completing the square is the first method that we have that works for any and all quadratic equations. All right, guys. First step is A equal to 1. If not, make it so. Step 2, get the constant terms by themselves and leave 2 spaces. Step number 3 is to find C, which is equal to B over 2 squared. And plug in. And lastly, we need to factor our perfect square trinomial. We need to factor and solve. Now, we did have these steps before. We had them on Friday, but I went on and put them up there again so that we have them again. Now you're good. All right. And we'll be repeating these steps throughout. Now, x squared minus 16x plus 64 equals 100. Oh, we did this one on Friday. We'll go on and do it again. Because we did this one on Friday, we did it a little differently than we're going to do it here. Because when we did this on Friday, the first thing we did was factor x squared minus 16x plus 64, and then went from there. So, and the reason we can do that is because, well, x squared minus 16x plus 64 is already perfect square trinomial. That's the whole process. That's the whole first 3 steps of completing the square, is getting that perfect square trinomial so that it will factor and we can solve. So, we come to this here. We're going to say we didn't notice that it was a perfect square trinomial to begin with. It will still get us, and still complete the square will still work. Because our first step is a equal to 1. Is the number in front of x squared 1? Yes. Because there's not a number in front of x squared, so it is 1. So we can move on to step 2. Get the constant terms by themselves and our variables on the other side. Really, we want x squared and x on one side, our numbers without x on the other. So to do that, we would subtract 64. We're going to add or subtract and move the numbers without x to one side, our numbers with x or x squared on the other. So what that gives us is x squared minus 16x plus blank is equal to, well, 100 minus 64 is plus blank. Now we leave two blanks because, well, we need our perfect square trinomial. We need to find that value of c that will give us that perfect square trinomial. And we're going to add it to both sides because I can't just add something to one side. We also have to add it to the other. We need to keep it equal. Now, questions on steps 1 or 2 before we move on to step number 3. Step number 3, we need to find the value of c that will make this be a perfect square trinomial. Now, c is equal to b over 2 squared. What is our value of b? It is 16, but it would also be negative 16 because we take the number and sign. And really what this is relating back to is our ax squared plus bx plus c. So we want the number and sign in front of x. So it is 16, but we'd also take the negative with it. So it is negative 16. Questions on that there? We want the number and sign. Okay. First thing we can do is divide by 2. Negative 16 divided by 2 is negative 8. Negative 8 squared is 64. Kind of ironic, yes? Because that gave us our quadratic back to being what? X squared minus 16x plus. And if that looks familiar, it should. Because that's literally what we started with. So now we just need to factor it. So we'll have our set of parentheses squared in x. Now the number and sign that go inside the parentheses with x is the number and sign of the number inside the parentheses before we squared it to find c. So that means we will have x minus 8. So x minus 8 squared is our x squared minus 16x plus 64. On the other side, 36 plus 64 is 100. So really everything we did in the first, or our second step, we literally undid in the third. But again, this only happens this way if what we started with was a perfect square trinomial. Now at this point here, any questions before we start solving? Square root both sides. Now the left-hand side, this is kind of nice because the square root and square will cancel, telling us that x minus 8 is equal to plus or minus. Anytime we take square root of both sides, we have to add the plus or minus. Now the square root of 100 is exactly, it is 10. So we get x minus 8 is equal to plus or minus 10. And lastly, we need to add 8 to both sides, because our negative 8 plus 8 would cancel, telling us x is equal to 8 plus or minus 10. Questions on any of this here? Are 8 and 10 like terms? Yeah. If they are like terms, we have to add and subtract. We'll have 8 plus 10 and 8 minus 10. Well, 8 plus 10 is 18. 8 minus 10 is -2. If they are not like terms, we can't actually add or subtract them. We can leave them as the single expression with the plus or minus. And we'll see some of those here in a minute. questions on this here? I more or less showed this just to emphasize that this does work. Even if we did start with a perfect square trinomial, it'll just emphasize the fact that it was one to begin with, and we can go on from there. Now, we're going to skip this one mainly because this is already a perfect square trinomial. So I'd hate to do two of these in a row where we get just subtract the 9, find C, add 9 to both sides. We just go in a circle. Let's look at this one here. X squared minus 4x plus 8 equals 0. And really, this is not a step there, but it is helpful if we had x's on both sides. We have numbers on both sides. Try to get them together. Get the numbers together, our terms without x, our terms with x squared, our terms with x, on the same side so that they're together. Now, for the most part, especially for this one here, is a equal to 1? Yes. We move on to step 2. So even if there was x's or terms on both sides, the fact that a is 1 doesn't have any impact. Or the fact that they're not together doesn't have a big impact. Because our next step is to get the constant terms on one side and the variables on the other. Well, for us here, the only term we have to move is our 8. So we can subtract 8 from both sides. Because on the left-hand side, we'll have our x squared negative 4x plus blank. 0 minus 8 is negative 8 plus blank. Questions on this so far? So steps 1 and 2 are done. That means we're going on to step number 3. We need to find the value of C, which is equal to b over 2 squared. Well, in this case here, what's our value of b? Negative 4, because we need the number and the sign. Now, we could put parentheses negative 4 over 2, close parentheses, squared, let the calculator do it for us. But it is kind of nice to do our negative 4 divided by 2, which is negative 2, because that is going to be a part of our factoring. And negative 2 squared is 4. So we'll have 4 and 4. Questions on this here? Okay. X squared minus 4x plus 4 equals negative 8 plus 4. So we need to factor. So we'll have x. Number and sign that goes inside our parentheses before we square would be negative 2. Because it's the number that was inside the parentheses before we squared it to find the value of c. So we have negative 2. On the other side, negative 8 plus 4 is negative 4. Questions on this here before we start solving? To solve, we need to do what? Take the square root of both sides, because here our square root and square will cancel, telling us that x minus 2 is equal to plus or minus. Well, we need to take the square root of negative 4. Now, looking at this here, we know that the negative is going to come out as what? I, which is just going to leave us with the square root of 4. And the square root of 4 is 2. Which means that the square root of negative 4 is 2i. Last but not least, we need to solve for the value of x. And we need that by adding 2 to both sides, because our negative 2 plus 2 will cancel, telling us that x is equal to 2 plus or minus 2i. Whenever we add or subtract a number from both sides, we'll put it in front of the plus or minus. Questions on how we got to this point here? Are 2 and 2i like terms? No. I don't have to break it up into two separate equations saying that x is equal to 2 plus 2i, x is equal to 2 minus 2i. This is it. We only have to break it up into those two statements if they can reduce. Questions on this here? Figure it out? Yeah. And just one more step. Yeah. All right. X squared plus 8x minus 5 equals 0. Is a equal to 1? Yes. Means we can move on to step number 2. We need to get the variables on one side, constant terms on the other. And we can do that by what? Adding 5 to both sides. Telling us that x squared plus 8x plus blank is equal to 5 plus blank. We're just giving spots so that we can plug our value of c back in. Now c is equal to b over 2 squared. And our value b would be 8. Specifically, it would be positive 8, but yes, 8, because we take the number and the sign. 8 divided by 2 is 4, and 4 squared is 16. Questions on this so far? So we good with this here so far, yes? Side note, this is not overly important, but technically we don't necessarily have to add it to both sides. What we could do, and I'm going to end up erasing this, is that I could add the 16 and subtract it from the same side. That seems like an odd thing to do, especially when we've been used to adding it to both sides, yes? What is 16 minus 16? So what did I technically add to this equation? Nothing. So we can either add it to both sides, which is essentially nothing's changing, or I can add and subtract it from the same side. Now, the main reason we would add and subtract from the same side is if we're dealing more with some of our, it's ellipses and hyperbolas and parabolas, where we're dealing with some other properties to it. Here, we can just add it to both sides. And it's going to work better to just add it to both sides than to add and subtract. Because if I add and subtract, I'm going to have to add the 16 over to the other side anyways. Doesn't help me. All right, factoring. Now the number and sign of what's inside our parentheses before we squared it, define c is positive 4. So we're going to plug in x plus 4. Squared is our factors. Equals 5 plus 16 is 21. Now at this point here, we're going to have to square root both sides. Over here, the square root and square will cancel, telling us that x plus 4 is equal to plus or minus. Now we need to take the square root of 21. No. Clear all that out. Second square root 21 is, well, square root of 21. It doesn't reduce. There is no perfect square factors. Like say the square root of 24, or square root of 6. If it reduces, reduce it. The 30xs, the little yellow calculator, will reduce radicals for us. But since it's just telling us it's square root of 21, We'll leave it as the square root of 21. Questions on this here before we finish solving? All right. Last step we need to do is subtract 4 from both sides, telling us that x is equal to negative 4 plus or minus the square root of 21. Now, before we say we're done, are these like terms? Nope. So, that's it. Questions on this here? I didn't point it out, or students say earlier that this is really just square root method, just adding a few steps to it. Stuff we've done already, just a few more steps. Questions on anything we've done so far before we start this here? We feel good with this here? All right. Is A equal to 1? If not, make it so. Well, what could I do to 3x squared to make it just be x squared? Yeah, we can divide by 3. Because 3x squared divided by 3 is x squared. So the value of A has become 1, yes? But if I do it to one term, I have to do it to all of them. Now, luckily for us here, this isn't too bad. Because our next one, 12x squared divided by 3 is 4x. Plus 15 divided by 3 is 5, and 0 divided by 3 is 0. Now, these here, making sure our like terms are on the same side is going to be important. Because a lot of them, I think, especially on the homework, it's going to be easier to work with if all of our x's are together. So we don't have x's on both sides of the equation, or constant terms, terms without x on both sides. Get them together first before we start our steps. Because now A is indeed 1. So now we go through the same steps. We get the constant term by itself. So we can subtract 5 from both sides, which tells us that we have x squared plus 4x plus blank is equal to negative 5 plus blank. C is equal to b over 2 squared. Well, our value b in this case is positive 4. This one works out kind of funny. 4 divided by 2 is 2. 2 squared is, yeah. Yeah, x squared plus 4x plus 4. Our value of c ends up 4. B and c end up being the same. Factoring. So we have our parentheses, we have x, and the number and sign that go inside this parentheses is the same as the number and sign that was inside our parentheses before we squared it. So we have plus 2. So x squared plus 4x plus 4 factors 2x plus 2 squared equals negative 5 plus 4 is what? Negative 1. We're ready to solve. So our first step in solving is to take the square root of both sides. Well, here the square root and square will cancel, telling us that x plus 2 is equal to plus or minus. We have to take the square root of negative 1, yes? Well, what is the square root of negative 1? Yeah, I. By definition, it is I. I is the square root of negative 1. So in some of the nice cases, if we just end up taking the square root of negative 1, it's just I. And last but not least, we need to solve for x by subtracting 2 from both sides, telling us x is equal to negative 2 plus or minus I. Questions on this here? Here right now, we're not going to end up doing that. So, we're ready for the next one. Negative 3x squared minus 18x minus 6 equals 0. Well, all of our terms are like terms, are all together on the same side of the equation. Is a equal to 1? If not, make it so. What do we need to do? Divide by what? It would be negative 3. Because it would be 3, but we want it to be negative. Because if we just do 3, our negative 3x squared divided by 3 would be negative x squared instead of positive x squared. We need it to be positive x squared. Negative 18x divided by negative 3 is going to be positive 6x, and negative 6 divided by negative 3 is going to be positive 2. So it tells us for this here we have x squared plus 6x plus 2 is equal to 0. Gets the constant terms by themselves and leave 2 spaces. Well, we can subtract 2 from both sides to give our x squared and 6x on one side, negative 2 on the other. Do we have to write the b? Do you all have to write b over 2 squared every time? No. You all can just plug in the value of b. I rewrite it out every time just as a reminder what c is. C is b over 2 squared. Well, our value b is 6. 6 divided by 2 is 3. 3 squared is 9. Factored form, we'll have our set of parentheses. We have x, and we do have the square. And the number that's going to go inside the parentheses with x is positive 3. Because we had positive 3 before we squared it to get our c value of 9. So inside the parentheses would be plus 3. The other side, negative 2 plus 9 is 7. Last but not least, we need to square root both sides. Again, our square root and square would cancel, telling us that x plus 3 is equal to plus or minus. Square root of 7 is square root of 7. It doesn't reduce. And last but not least, we would subtract 3 from both sides, plus or minus the square root of 7. Since, again, they're not like terms, we're done. Because when we square root both sides, if that term, especially on the plus or minus side, has a radical I or a radical and I, we're not going to be able to combine them for this here. Questions on this here? We feel good with this so far, yes? Now, up to this point, we've seen graphing works well in some cases. Factoring works well as long as it's factorable. Square root method works as long as we have a perfect square or a term squared by itself. Yes, all of them at this point have had something to them that made them not as nice. Yes? We're skipping this one. We're going to look at this one here. It still works. We can still find the solutions. It's just a little funky. And yes, this isn't on your note sheet. So I added this one in so that y'all can see this here. Because if we look at this here, like terms are together, is A equal to 1? If not, make it so. So we're going to divide everything by what? 2. Okay. Half of this works out nicely. Because 2x squared divided by 2 is x squared. Minus this 5 divided by 2. Nicely. Now, so we have two options. One is to turn it to a decimal, and the other is to leave it as a fraction. It's going to be nicer to leave them fractional than it is to put them decimal. It's going to be nicer to leave them as a fraction than it is going to be to leave them as a decimal. Plus, well, again, 67 does not divide by 2 nicely. Luckily, 0 does divide by 2 nicely because it is 0. Now we do have a value of A that is 1. So we can move on to the second step, getting the constant terms by themselves. And leaving 2 spaces. All right. Questions on this here before we find the value of C? C is equal to B over 2 squared. Well, in this case, our value of B is negative 5/2. Now, up to this point here, finding this, halving it to find our value of C, for the most part, has been nice because it's either we cut it in half or we leave it as a fraction. This here is not as nice, but 30xs will do it just fine. Negative 5/4. And again, the calculator will square it for us. Guys, it is 25/16. Now, up to this point here, trying to factor x squared minus 5/2 x plus 25/16 would not have been as nice. But I do know the number and sign that go inside this parentheses. It would be negative 5/4, because it's the number and sign of the number inside the parentheses before we squared it to find C. So it gave it to us there. Questions on this so far? Now the question is finding out what negative 67/2 plus 25/16 is. Is negative 511/16. Yeah, it's a big number. Questions on this here? Well, at this point here, we have to square root both sides. The left side's nice because the square root and square would cancel, telling us that x minus 5/4 is equal to plus or minus. All right, we're going to take square root of negative 511/16. Well, the negative, we know it's going to come out as what? I. It's going to come out as I, which really leaves us with the fraction square root of 511 over the square root of 16. Now, I did this for 2 reasons. One, we have to break it up if we're plugging it into the 30xs. That's part of the reason we took the I out. The 30xs little yellow calculator does work better with these here than the graphing. Because I can come over here and say second square root of 511 over second square root of 16. Well, hey, what is the square root of 16? 4. And the square root of 511 is, well, the square root of 511. It doesn't reduce. So the square root of negative 511 over 16 is the square root of 511 over 4i. And last but not least, we need to add 5/4 to both sides, telling us x is equal to 5/4 plus or minus the square root of 511 over 4i. Because those are definitely not like terms, because one of them has a radical and I, and the other one doesn't. So that's it. Questions over this here? Would we say that this is any harder than the previous? Not as nice. I wouldn't say it's not as nice because we're having to keep track of these fractions and radicals. It has a lot to it, but as long as we keep all that straight, it's not that bad, and the calculator helps us with pretty much all of it. That is it. You have 8 problems, 7 of which are completing the square. 1 is error detection. Number 38 is error detection. I will give you a hint with error detection. It's formula. They did something wrong with the formula. Specifically, it's about finding C. Just state what they did wrong or what they left out and find out what the correct value should be. And that's